Okay, now we're ready.
Okay. Okay. So I was nervous that I was going to be first or third presenting, but this one actually wasn't so bad. So I was very good. So for this one, we had to return a sum of all the multiples of 3 and 5 below a certain number. And I almost got it all by myself. I don't know, I have so many comments here. So here's my function solution. Here's the number that we would be using. So I started with a sum of multiples equaling 0. I created a for loop. I equals 0. The initial thing I did was I said if I was less than or equal to the number, and I got an error, and I couldn't understand why. And then I realized I was adding the whole number into it. So I took that out, and it worked. For each iteration, I increased I by 2. This part I knew right away I was going to do to find the multiples. I think we've had exercises like that in the past. And then if it returned 0, then I would add that to the sum, the ongoing sum that was happening. And then, of course, like my number one thing I always do, I forgot to include a return. So I kept changing things around, but it was just because I hadn't included a return. But once I did, it worked. So I thought it was a pretty simple exercise. I was quite relieved that it worked out that way.
Nice. And so you ran it on the code words. You tried the tests are passing. Okay.
The tests are passing. Once I put the return in, and once I got rid of the I is equal to, less than or equal to, it passed. So yeah.
Nice. Yes, I thought it was not that hard either. It's the pointing system that says 6 KWIYW. So these 6 points, but I think it's quite straightforward also. When I was reading that, because I also did this now for the first time. I did not do this before, but I thought there would be some kind of trick where it says that if it is a multiple of both of them, it should return it only once, so that you should have like 2 or 3 different if cases or something, so that you manage all cases. But with this, just like this, it works fine. This is one or the other, and if it's both, also it just counts it one. So anyone tried something different?
I also thought about that case where I was nervous it was going to return more than one, so I did some if cases, and so it's a bit longer, but basically the same thing.
Yeah, I don't think there are many variations in this exercise. I don't know if anyone thought something really different, like totally different, instead of an if case. So okay, nice. You can also, of course, yes, do it with a while case. But something that should be totally different, I didn't see also on the solutions that I saw online. I don't think there is any. So it's quite straightforward. Yes, starting the summary and then for loop and an if. Nice. Okay, I'll send you the one for Friday then, for our next presenter. And let's start with the lecture then. Let me share my screen. That will give us a bit more time because this lecture is a bit long. I hope we can. So you can see the slides. Okay. So the lecture is called DB modeling, but in fact is more of advanced database than DB modeling. And what we will cover is some more of the database relationships, of the table relationships. I don't know if we have mentioned, probably many of you have already, if you checked on your own and you have seen resources online, you know that we will have like the one-to-one, one-to-many, and many-to-many. So we will analyze a bit more how the tables relate between them, these 3 types of relationship, different constraints that we have, especially the foreign key constraint. We mentioned this briefly, but now we will see it a bit more. and some more select parameters that we can pass, so to make our selects a bit more specific. And the last two is more related to the backend, so how we can write some code on our Express server so that when we send the results back to the client, we don't just send the result, but we kind of modify it and put them in a better format, a more useful JSON format for the client. And also the guards, the middleware, we have already seen this. These are the functions that will help us do some checks every time instead of repeating code. So we can do some checks with that. We have seen an example, but we will see it again a bit more today. So some of these things you have already seen. And if you worked a bit more on the databases on your own during the MVP phase, you also probably studied this a bit more or found some resources. But also today, it's a good opportunity for solving any doubts. So remember, we had this example with the Excel and the classes and students, and we saw how we have the way of storing, let's say, data in a spreadsheet, that it's a more flat format and creates a lot of data duplication and also doesn't allow checks and error checks, so that it doesn't allow us to check the data integrity. And then how we could use actually a database to reduce this data duplication, and we have fewer inconsistencies, fewer errors, and use less space as well. So the example that we have seen was this one, that we had the student and the classes, and we have seen how we would typically write this table in an Excel format. So first name, last name, the class, the teacher. So here we were kind of repeating information, for example, the class name and the teacher name. And so when we wanted to change it in one place, you have to change it everywhere. And instead, we saw this way of doing it with the databases, that we separate the students and classes into different tables. And so we have our students here and just connect them with a client, with a class ID to a different table. So we saw how this connection worked using a foreign key. So this ID here that makes reference to another table, it's called a foreign key. And in this case, our relationship between the two tables is a one-to-many, because each student, we set that as a constraint, that each student can have only one class, so can be only enrolled in one class, but each class has many students. Okay, so it's a one-to-many relationship, and we didn't get much into what exactly this means, but we will see today what type of relationship we have apart from that. This is the most common, actually, the one-to-many. So the relationships are how we make a connection between the tables, and there are three basic types: one-to-one, one-to-many, and many-to-many. We go to, yes, I think these are all explained better with examples. So a one-to-one relationship is not the most common, basically because instead of having two tables, if you have a one-on-one relationship, most of the time you can just store everything in one table. So let's say, for example, a one-to-one relationship is a country with its capital. There is, each country has one capital, and each capital belongs to one country. So here we have a one-to-one relationship. And when we have this type of relationship, maybe you would think that instead of using here on the countries a capital ID and connect it to a different table, it would be even easier to just put in here capital name, let's say. So you just join everything in one table. So in this case, you may not separate into different tables unless your tables have many lines of data. And so you may want to separate them just for clarity and for breaking them down to smaller pieces of code. Same as you would do with functions, that when a function becomes too big, then you start breaking it down. So if a table becomes too big, you could break it down and create this kind of connection. Although the most common would be that you just put everything in one table if you have a one-to-one relationship. The most common is the one-to-many, the one that we have seen also with the student and the classes. So let's say that we have customers and purchases. And so one customer can have many purchases, but one purchase can be made by only one customer. So this is the way that we symbolize this relationship of one-to-many. You see here this symbol. When you use this kind of SQL drawing programs, you will see that you can use these connectors, these lines that they show that from one customer we can go to many purchases, so that we have a one-to-many relationship. So this is where we use the foreign key. And we have our customer information, and then on the purchases, we have the purchase information, and then we connect it with one customer by using the customer ID that makes reference to the customer that made that purchase. So in this case, the language that we use is that we say that the customers is the parent table, the one where the primary key comes from, and the purchases is the child table, the one where the foreign key is hosted. We have already seen this language before, like parent and child. We have seen it when we were using classes. So we had like a parent class, and then we had the child classes, the ones that they were inheriting information from the parent class. In this case, the table doesn't inherit any information, but it's just connected with a foreign key like this. We have also seen this parent-child when we do components. So we have like the parent component, and then we have the child components. And so this is a common way of using this language when we talk about this type of connections. Okay, and so the normal way to deal with this type of relationship is by using a foreign key. And we have this foreign key constraint that will also help us in case that we want to modify the data, so that we have to delete, let's say, some data. Because, okay, we'll see this next. But we have to decide what will happen. So in this case, for example, what would happen if a customer was deleted from our database? So let's say that the customer wants to unsubscribe or to be deleted. So what will happen with the purchases that are connected with this customer? If we have this foreign key connection, then this will allow us to connect the two data, the two tables together, and will allow us to understand, to decide what we want to happen, if we want to also delete all the purchases, or if we want to modify them and set the customer ID to null, etc. And so there are three options that we have that we will see right next. And then we have the many-to-many relationship. And we have not, I think we have not seen it. I don't think in any of your MVPs you had a many-to-many relationship, or maybe I don't remember now. An authors and books relationship, for example. This could be an example of, we have authors, so the information about an author, and each author can have many books, can write many books. And then a book can also have many authors. So it's not that one book has just one author. One book can also have many authors. So the connection between the two tables of authors and books would be something like this. So from many to many. This is a way that we symbolize this relationship in theory, because we say in theory because when we want to implement this cannot be done like this. This is not, this doesn't allow us to do this information, because we cannot kind of cross foreign keys like this. And what we do in reality, in practice, is that we use this junction table. So we need kind of an intermediary table that will help us do this connection. And instead of being a many-to-many direct, it's a many-to-one and a many-to-one with this table in the middle. So if we have this authors table, and then we have the books table. We normally will create an authors books table that will have the foreign keys from both tables connected. So here we will have the authors from one side, books on the other side, and the middle one will connect each author with a book ID. We will see this in an example that we will do on a demo. So in practice, when we want to create a many-to-many relationship, we also need to create a third table in the middle that is called the junction table to implement this. And in this case, this author ID, it's a foreign key. So we would set this author ID to be a foreign key that refers to this ID. So this will connect with this table. And this book ID, it's a foreign key that connects to the other table from the other side. So this author's book just has these two foreign keys in it. So the constraints that we have when we want to help us maintain the integrity of the data that we have stored in the databases, we use some constraints that help us. One of them, for example, is primary key. So when we set that one ID is a primary key, this is a constraint. That means that this will be used as a primary key, and also automatically will make this a unique. It's a typical thing when we set the ID for a table that we set it as a primary key, and also that means that since it's a primary key, it has to be unique. We cannot have two duplicated IDs. And not null, it's also a constraint, so that a field cannot be left empty. If we try to leave it empty, we will have some error triggered. The unique is also a constraint. It's similar to primary key, just that the primary key includes more information. So a primary key is unique, but we can also set some other field to be unique. So for example, email can be unique. You don't want to have two people with the same email. And so you can set that an email, it also has to be unique, or even though it's not a primary key. Primary key has more information in it because normally we use a primary key for doing searches on the database. So for doing our selects and for doing inserts, for anything that we need. So we use this as an index, and it has to be fast. It has to be connected with a quick way of searching the data. So a primary key has more information in it than simply being unique. And then we have the foreign key constraint, which is, as I was mentioning before, what will allow us to define what we want to happen when a parent record is deleted. So in our example before, we have the customers and we have the, let me open this here, just to check. So we have the customers and we have the purchases. And what will happen if a customer is deleted? There are three things that could happen. So we have three options. One, we also delete all the purchases. So when a customer is deleted, we also delete all the purchases that are associated with this customer. This is what would be the cascade option. So when we set that on delete cascade, so here is our purchases table, and we have the foreign key set connected to the customer ID. So the foreign key in customer ID makes reference to this other table. And then at the end, we specify what will happen on delete of the parent entry, of the parent record. So here is where we will specify what option we want from the three. Cascade will be that we'll also delete the children entry. So we'll also delete the purchases that are connected to this parent. Set null, it's the other option that we have. That means leave the purchases because we may want to keep it for historical reasons, because we want to have it in our company so that we know that these purchases were made. But now they cannot have any customer ID because there is no customer associated with them anymore. So instead, we will replace the customer ID with a null. So set null means that we will make the children orphans. They will be set to null and they don't have an association with a parent. And restrict will actually forbid us from deleting a customer who has purchases. So we could define on delete restrict, and that means that at the moment I'll try to delete a customer, it will say you cannot delete this customer because it has associated purchases. And so first I have to go select all the purchases associated with this customer, delete those first, and then delete the customer. So these are the three options that I have. The most common could be the constraint, the cascade, so that when you delete one, you also delete the other so that you don't have any orphan entries left. But this is our choice. So when we define a foreign key, we can define here what will happen. And in fact, the default, let me say default foreign key on delete, not sure which one is the default behavior. Restrict, I think is the default behavior. So this one, I don't remember. I would have to check which one. If you don't specify anything, so you just set the foreign key, but you don't specify any on delete behavior, one of the three would be the default. I think the restrict, the default one, but I would need to check this out. Okay. So let's see. Any questions from this first part with a relationship, one-to-one, one-to-many?
Only one little question. So the usual thing you do is that the parent element, its ID is always called ID, and then when the foreign key, this ID is a foreign key, is only in the child element that you call it like with the name, let's say.
Yes.
Like, I don't know, the parent is the customer, is ID, and then the child will call this ID, this foreign key, parent ID, customer ID, for example.
Yes, exactly. Yes, that would be the common way. So the ID,
Okay.
we use it all the time as a primary key. So normally all the tables will have like one ID. That is their own ID. And then when they use an ID from someone else, this you can name as you like. You cannot name ID again because ID you already use it. So you have to use some other name, and a common way would be to connect it with the table so that you remember from where this ID comes from.
Obrigada. Thank you.
Some more. I don't remember, have any of you used this? Has any of you used this many-to-many relationship in some of your MVP? Think not.
Is many-to-many relationship something you'd use if, for example, because working with kind of setting up user logging, user verification, if you have different users that have kind of different information stored in the database relating to the application?
It would depend if this information can also has many users associated with it. So that's what could it be like? Each user has many classes. So for example, yes, if we are talking about students, so your users are your students, and then each student can be enrolled in many classes, and each class can have many students. So this could be also a many-to-many. Okay, so then about the joins, this is also something that I think some of you have used. We have seen a bit briefly when we did the first part of the databases. So when we are trying to do a select from different tables, so right now we have seen that we have different tables and there are connections between them. Sometimes we want to get information from more than one table at the same time. So let's say that we have this kind of structure, authors and books, and we try to make a select that will not be select all authors or select all books, but to have them, the two tables kind of joined together, so that I want to select the authors and the books of these authors, so that the information that I want will be like a new table with authors and books all together in one, not table, because we don't create a table, but in one result. So that the result that I will get from that select will be a connection of more than one table, or the customers and purchases. So it doesn't have to be on the many-to-many relationship. Also here, so I want to get a customer and all the purchases of that customer. So it's kind of a double select, because I select from a customer the customer information and also select from the purchases the customer purchases. And I want to bring all this the information from the two tables together. So for doing this kind of selects for more than one table, we use joins. And get to joins. So join let us return results from multiple tables in one single select. Instead of selecting from one, storing the result, selecting from the other, storing the result, and then ourselves trying to do the mapping on the JavaScript and get things from one and the other, you can make MySQL do that directly by joining the two tables. And let's say, for example, that I want to get all the purchases for a customer with this ID. So I don't really have to first select from the customer where ID 1, 2, 3 and select first name and last name, and then go to purchases where customer ID is 1, 2, 3, and then get the rest. I connect the two in one select. And so I select everything from customers. So I select the ID, first name and last name. And from the purchases, the date, time, and the total. And from which table do I select this? Because now I'm talking about two tables. So I'm going to select these fields from the join of these two tables, from customers, left join purchases. So I define that I'm going to join customers and purchases table with the left join. We will see what is a left join, so what other types of joins we have. So, but we join these two customer and purchases table. And how do we join them? We join them by using this connection that they have, this common ID. So we join them where the customer's ID will be equal to the purchases customer ID. Okay, so the customer's ID is equal to the purchases customer ID. So this is how my connection will be done. Then I can specify something more concretely. Here, I don't want to simply join the two tables with all the customers and all the purchases. I could also do that if I want, but in this case, I'm searching for a specific customer, so I can specify where a customer ID is 1, 2, 3. And I could also specify something else. This is also optional. So let's say how to order the results by, with an order by field. So in this case, I could say that I can order them by the date that the purchase was done. So what is a left join, or what are the types of joins that we have that will allow us to join these tables together? We have the symbol join, so the inner join, we can just write join, you don't really have to write inner. And this one returns only the matching values that are in both tables. So this is the first table that you specify, and this is the second table. The order that you specify the tables on your select will be the one that will define also the order here. So the inner join will take our customers table and will take our purchases table and will also give us back the common part. So the ones that are found in both tables. So let's say if a customer doesn't have any purchases, then this customer will not be returned. Okay. In our case, in the example before, we were searching for a specific customer, but let's say that we were trying to simply put together the two tables without specifying for which customer. So if there was a customer that didn't have any purchases, so that there is no common part with the second table, then this customer will not be returned. And so the inner join returns only the matching values. And let me see, it's easier to see. Similarity. I have an example for this. Just 1 second. See where I have this example. Well, I'll continue with the rest and then I'll show you the example because I have an example so that we see this in action. It's easier to understand it when you see the result. I have this. So this would be the inner join. Okay. So yes, this would be the inner join that will bring together the common only fields. Then we have the left join. The left join will return everything from table 1, even if they don't have any entry matching on the table 2. And from table 2, we will just return the matching ones. So we return all the records from the left table and only the matched records from the right table. So in this case, in our example before customers and purchases, if we have customers without any purchases, we will also get these customers with null on the purchases information. So we get all customers, and also if they have a matching purchase, we will also see the purchases of these customers. If not, we will see null, but we will still get all the customers. And the opposite happens with the right join. So let's say table 1 is customers, table 2 is purchases. If we had any purchases without any customers, let's say we had deleted the customer that did this purchase and we had null, then we would still get all the purchases, even if they don't have any customer related to them. And the ones that they have some customer, we will see the customer information here, the right join. And then the full outer join will put together the two tables, so we will get all entries from one and all entries from other, not only if they are matching. So I have created for this a database just to check it. So we have this customers and purchases table, and I have created this foreign key constraint for the customer ID. And then I inserted some data so that we have some data to try and do these purchases, these joins, and see what the information that we have. So in this case, we have 3 customers, 1, 2, 3. And we have purchases, but if you see the customer ID, we only have purchases from customer 1 and 2. Customer 3 has not done any purchases yet. Okay. So let's see what happens if we try to do each one of the different joins from this. So I have my database here. No show tables, no show databases. This one is, I think it's the demo. Yes, this one is customer and purchases. So describe purchases. Yes, okay, so it's this one. And I think I have already inserted the data. Yes, so I have already done these two first things, created the tables and insert the data. So these are my data, the ones that are also inside the database. So let's try a select, I will write it here directly. So select customers, all the same as we have here, this one. Let's try to replicate this one and see what results we get. Purchases, date time, this is total from customers, left join purchases, customer ID equals this. And I will not even specify.
Anna,
Yes.
there's a typo in the first customers. There's an R.
Customer. Here.
No, after select.
Ah, yes. Thank you. Yes. It's good to have some extra pair of eyes because I would have to search for this. Customer purchases, customers, and here it should be plural customers also. Customer ID. Okay, I will skip the constraint so that I get all customers. So not only the ones from the 1 to 3. And let's skip also the order by and just do the select like this. So this is a left join. And let's have this also here. Remember that the left join means that I will get everything from table 1. In my case, table 1 is customers because it's the first one I put. When I use the left join, the one that I put first, it's the one table 1, and then purchases is the second table. And so what I got is all the customers, even if they didn't have any purchase. So I got everything from the first table. And then if there were some matches, I also got the matching information from the table too. But like this, I get the first name and last name, and also the date of a purchase and the total price of a purchase. So the information from the first table and the information from the second table joined together in one new table. This table doesn't exist on the database, so it's not really a table that I created. It's just a way to show me the results. But this is the result that I will get if I do this select. I would get this array with this information inside. The customer name is duplicated because, of course, it has more than one purchases. And I also get the customer without any purchases because it was a left join. If instead of a left join, so I'll try to do the same and I'll just do join. So if I just do join, it's the inner join. So it will just show me the common things. And you see that in this case, the last customer is not shown because it doesn't have any matching information on the other table. And so I just get the ones that are found, that can be found in both tables, that they have the matching. And so if I do a right join, so sometimes the joins can also return the same result because, for example, in this case, the right join, I don't have any purchase that is not connected with any customer. So in this case, the join and right join will give me the same result because in this case, there is no purchase with the customer null. But if there was, I would get also this information from that purchase without any information on the first name and last name. So here I would have null, and then I would have that there was a purchase on this date and with this total. And then if I try to do the full outer join, yes, I think this one I have to check. It does, yeah. It depends on the SQL version and on the SQL server that the how you write it. So this one doesn't like full outer join. I tried to find yesterday how this was for this server, but it's not called full join either. No. So for this, I will have to check it to see how you write full outer join for this server, because sometimes the syntax of the SQL changes depends on if you use MySQL or Oracle or SQL or whatever. So this one this server doesn't accept this. But the idea with this would be that we would take a full table. It would look basically like this because we don't have any purchases without any customer. So the result that we would get in this case would be similar to this one. There are also in this website, the SQL joins. There are two tables that are like a demo also tables, and you can play a bit with it if you try it yourself and see what you will get in return if you change some of these. So if instead of inner join, you write something else, and then you run the SQL and you see the information that you get, if it is inner, if it is left, or if it is right, so that you try it a bit more if you like. And you can modify this so that you can come and play with it and run SQL again and see the result that you take. Okay, so this for the joins, do I have? Oh, nice. Okay, Khan Academy. Very useful tutorials. Yes, I also like videos. So normally the inner join or the left join are the ones that we use more commonly. So a left join is the very common one, and the normal or the inner join also as well. And so sometimes you can get the same answer as well, depends on the data. And and so you can also join three tables. So you can have kind of a nested left join structure. So you can join more than one table, especially when you have this many-to-many relationship where you actually have three tables involved. So this is like an extra step, but you could do that as well. So you could say from customers left join purchases left join, so that you can like nest the left joins as well. Another good thing, good to know thing for when we're working with database and with SQL commands is the alias that will allow us to write less words, to have our syntax, the SQL commands a bit less verbose. I think we have seen this in the past as well, but the use of it is that we specify an alias for a table name so that we can use like a shorter format for it. So let's say we have this same SQL command as before, select customers all, purchases. So here I'm repeating a lot, customers, and also here, and then purchases. So I'm repeating a lot the same word. And if I want to make it a bit shorter, I can use the as keyword, like that would represent alias. So I specify that I will select C all, P date time, P total. And what is this C and P? This C and P, they are defined here. So where we define the tables. So I select from customers as C. So I will use C as the alias for the table customers. And I will use P as the alias for the table purchases. And so simply I can replace the word customers with C and the word purchases with P everywhere in my SQL structure here in the SQL command. So it's just to make your SQL a bit shorter and you can use it like this. And another way where we use this is when we want to redefine some of the structure that we get. So let me come to this command here. So I had this, and that would transform it customers and P date time, or even not date time, just the total from P from customers as C, join purchases as P. And this will allow us also to do less errors as before, so that I was having like an extra error somewhere, or I was missing an S. So when you have longer words, it's easier that you do more syntactic mistakes. And on C.id equals P.customer ID. So here I cannot replace it. This is not the table, so this is one of the fields of the column, so I cannot replace this customer with C, okay? Careful with this. So like that, I made it a bit shorter, but also what's one thing, so if instead of just taking the total from this table, I also was asking for everything from this table, so P asterisk, so in this case, I have two columns with the name ID, because I get one table has an ID and the other table has an ID. And now when I try to do this join, I get everything from both tables. And now we found with two columns with an ID. And I don't really like this, because when it will come to me, I will not know which ID is which. So what I can do also is to rename. So I can say that C.id as customer ID. So since I'm selecting all, but let's say, so I mean, I can use as well to rename one of the columns to something else. So let's say instead of doing the asterisk, I'm just picking up some information. So I just want the ID and the first name and the last name and the total. So let's say we want to select the ID, and I will rename this column to customer ID, and then also select the first name and the purchase total. And so I get this new information, but now instead of a simple ID that I wouldn't know if I had to get both IDs from the both tables, I wouldn't know to which table it belongs. I have renamed this to something else. So since when I'm using joins as, the alias can be used not only for renaming the tables, so not only in this part to say that instead of the name table customers, I will use C, but also for a column. So instead of ID, I will rename this to customer ID. So this alias is helpful for shortening and also for renaming in case that we will find that we have two tables with similar columns, and that will produce some confusion when we get the data. Okay, then we have some other functions that we can use that allow us to do some computing at the same time that we are doing the selection. So instead of getting the data and then us processing to do the summary of all the totals, we can do the sum directly when we get or when we select the data. So the count is the one that counts the number of purchases. So it just counts the number, the rows. So we can use, instead of select all, select count all. So it will count all the entries. It will not return us the entries, it will return us the number of the entries from purchases where customer ID is 123. So let me copy this. I don't have a 123, but I have a 1. And so it returns 2, just because right now I just want to know how many, let's say, this customer has done. So it returns that this customer has done two purchases. So I can use the count here, the count function, to just count, or I can use the sum. And so select sum total from purchases where customer ID is 1. So what we'll do, it will sum the information that is in the total column for the customer that matches this, that the ID is 1. So it will return me the sum of all the purchases of this customer. So it will return 500 in this case. So these are useful, and we have more than this, more like this. We have the max, we have the mean, so select max, select mean, and then we also have the group by. So these are all extra things that we can use in our selects to make our the data that we get back very specific, and so that we don't have to do post-processing of the data, but we directly process them while we get them from the database. So let's say that we want to calculate the total purchases for all customers. And so we do this sum total, but instead of doing it for one customer, I want to do it per customer. So that means I cannot simply like say, let's do it without any customer ID. No, because like this, it will get me from all customers, all the total, and this is not very helpful. What I want is that it does the total, but per customer. So for this, I can use the group by, and I specify that I am going to group it by customer ID. So I want you to sum the totals, the purchases that each customer has done. And so it will give me the total of one and the total of the other. I could also, if like this, I don't understand which customer is one, instead of just selecting the sum total, I could also select let's say, customer ID. Customer ID. And like this, I have which customer and the total of the purchases of this customer. So the group by allows us to group, to aggregate this function that I'm specifying for multiple customers. And as I was saying, we can also specify that we want more information from this customer. Right now, I was just taking everything from this purchases table, but you can also use the left join and get the name and first and last name from one table, and then join this with the summary of total from the other table, and then you group them by ID, and then let me run this. And then you get it in a nicer format so that you know which person has done how many, the total of purchases. By joining with a left join the two tables together. See that since it is a left join, I also get the one that is null. Okay, because I get everyone from the first table. You can always do this with more simple selects, that you get things from different tables and then you process them, or then you use them somehow. But it's, if you learn like the potential, the power of MySQL, it's quite big. The people that know very well the SQL language know how to do directly like magic with their commands. And they may be commands that they look like a function because there are 30 lines, but then you get, especially when you are dealing with big amount of data, you can get very specific and you can process it and do sum and count and whatever you like and get exactly what you want with just SQL. No need for much of JavaScript involved in this. So you can, there are a lot of things that SQL can do, not just do some selects and inserts. Okay, and so let's go now a bit more to our JavaScript. So we have done all this, we got some information from the MySQL, and let's say that we have not done a lot of processing on that information, we just got these tables, and we want to send the result back to our client. So we want to send some JSON to our client, but the format that we get from a join may not be the most useful. So let's say, let me come up here and I joined everything from both tables and I get this result or this result, okay, without the customer ID. So this format may not be the most helpful because it repeats the name a lot and it has some columns that maybe the client doesn't really need. And so especially for the repeating part, let's say that we want to get all customer purchases for this customer. So this join will give us this information. It will repeat the customer name. And if we just wanted to send this back as a result in a JSON format, we would get this array. So it's broken in two, but in fact it's one array, right? It didn't fit in the screen. So there is one array that has the first row, it's this first object with ID 1, 2, 3, the customer ID, first name, last name, and then purchase ID, total, and date time. And then the second object that we get, again, it has the ID, first name, last name, and then purchase ID, total, and date time. We could set this to the customer, and then we could have the front end deal with this data and what to show and how to show it. But a better way is to process this, and instead of sending this, so now you see it in the vertical format, send it in this format, a bit more useful. So instead of repeating ID, first name, and last name, since this part is common, we extract this, let's say, and we create this object format where the ID, first name, and last name is first, and then the array is just the purchases. So we have a purchases array, and then in here we just have the information from the purchases. This would be a bit more useful, and we wouldn't have to repeat for each one of the entries, the ID, name, and last name. And this we can do easily on the backend by creating some function that gets the results and process them and create this more useful format before sending to the front end. So there is an example here. You can also think of some other way to do it. So this is just JavaScript. You get this array of objects. So let's say you get your result of this select that you did, this select with a left join that provided you with all this information. So the route here, the route handler is, as we have seen, we get the results when we run this query. And then before sending it, we don't send the results. So we don't rest.send results. We send a more useful format of the results. So we create a function that will be getting the results and doing this mix and match, and then send the results to the front end. And what is this make useful format function? It's this one. What we want to do? We want to create the array of just the purchases. So the first thing that we do is we create this array that will be nested inside with just the purchases. And for doing that, we get our results, the results data, and we map each one of the results. We just get the information that we want. So if I go back here, this is our array and it has two objects. We want to create a new array, this purchases array, that will still have two objects. So I'm going from an array of two objects to a new array of two objects. So for this, I'm using map. Okay, remember this higher order function map. You can use it if you want to go from one array to another array of the same size. So we get this array, but we simply keep the information that we want from it. So I'm getting this array, and for each row of this array, I create a new row here, a new entry with just the ID, total, and date time. The purchase ID I can rename to ID, total, and date time. And I just keep these three things. So with the map, I'm getting each entry of my original array, and I just keep the ID, that will be the entry purchase ID, the date time, and the total. And once I have this purchases array, then I create an object. So this object that I will be returning will have only once the customer ID, first name and last name, and then it will include this purchases array. So I'm creating this new object, and instead of sending back the array of all the entries with some duplicated data, I'm just sending back one object that has the purchases array in it. This is, as I was saying, this is one way of doing. The idea here is to understand that it's not always useful to send the data just as they come from the database. So maybe you want to process them a bit, and so that we make the life for the front end a bit easier. And so we can use this kind of conversion functions to modify our data before sending them. Questions? You can interrupt me at any time, right? Don't wait for me to ask for questions. Is it clear?
Not a question, but I think this all seems so super useful, but like so much to keep track of, right? Like that's kind of how I'm feeling, but it seems really useful to know.
That's why this is a bit more advanced SQL, let's say, but since you have already used it a bit, now you are a bit more accustomed to the normal select, to the more first beginners, let's say, select. So you could try to add some of this more advanced stuff if you like. But as I was saying, it's not actually, you can do it in the easier way as well, just it will be more, a bit more code.
Can you like slowly go over the function, my
This one?
format? Yeah, I think I'm not getting
Mm-hmm.
the part where, so we do the map of it,
Mm-hmm.
and the purchases that we just reuse that variable down below where it creates that array. But like, for example, row 0 dot customer ID, that is just coming from the JSON data that we got from the routes. Is that correct?
Mm-hmm. Let me see if I can put it here in some code. So let's say, I think with a simple next file. Yes, I think if we just write, let's see, new entitled file. So instead of creating all the structure and everything, I will just copy as an array this, because this is what we get from the MySQL. So for obtaining this, you need to run the select and everything, but results. Then at the end, you actually have this array, and what you want is to transform this array to this object. Okay, so you want to transform it to this object that we want to send. And so for this, we use this function. So let me just copy it here. And it gets this results array as an input. And so the first thing is that we create the purchases table. Let me put this here so that we know what we want to achieve. So it creates this purchases table, which is this part, this array, not table, sorry, array. So we want to create this array. And for this, we get, in our case, when it comes from the database, it's not results, it's results.data, this part. So the array, it's stored in the results.data. That's why here it says results.data, but in our case, it's just results, our array. So we have this array that we got from the database, and then we map each row of the array, so each object, to a new object. And if we console log this, and I can, let's say, this in comment for now. So what we did was we got the array, and for each row of the array, we created a new object that will be the new array item with just the ID, and as ID, I put the original purchase ID. So I got in here and I got this purchase ID and I named it ID and I use it like this. So let me just call this part with results. Going to run it. Results. Let's see where I'm. Errors. Undefined, undefined. Purchase ID, date, time. This one is not date time. This is date time. And this one is purchase D. So in my original array, this one is purchase ID that I will now rename to ID. This one is date time that I will now rename as date time, and the total I keep as it is. And so if I run this, I get this smaller array with just the purchase information. So I have this part done, and now I want to create the whole object. So I'm creating this customer object. Row 0 is because the information for the customer, the name and ID and surname. So name, ID, and surname, it's repeated in all the objects. So I can just choose one of them. So let's say I choose the first item of the array, and I will take these three things from here. I don't have to take them from everywhere because this is repeated. So this row 0, it's actually like, I can just rename it like first item or whatever. It's just the first item of the original array that I have. So, and I get from this, I will put it back to row 0. And this first item, when we are talking with the databases, since what we get is on the results.data and the array is the data, we have to do results.data 0. In our case, it will be results 0. So I'm getting from my array here, I'm getting the first item. This is the results 0. And I want to extract from this one, these three things that are repeating in all the objects. So row 0 is just my first item, the results 0. And from this row 0, I will get the ID. So it will be ID, first name. So I will copy the first name and I will copy the last name. So I'm just choosing one of the objects to pick up to get this common information, and then I will create a new object that has the 3 rows of the common information and also add the purchases array in it. So these purchases, I could also write purchases equal to purchases, but remember that with JavaScript, if the two names, the key and the value, they have the same name, then we can skip it for shorter. So since purchases will be the same as what it's stored on the purchases variable, then I can skip this. So here I'm creating this new object. Now we'll have an object instead of an array. What I want to send back is this object. See how it starts with a curly, so it's just an object that has these three pieces of information as the first part, and then the purchases array that I created before with a map. And this row 0 is just for grabbing these three common things from somewhere on the original array. So from any of the objects of the original array, this is repeated. So I could get it from 0 or I could get it from 1. It wouldn't make really any difference, but 0, it's more safe because I don't really know how many customers I have. So let's say that I will have at least 1. So the result 0 will be always there. And then I return this new object. So let's say I will console log what this returns. This. And like this, I getting this object that has the ID, first name, last name that I got from one of the original items, and then the purchases that I created.
Would you say it's generally preferable to do like all of this work with the data on the back end, or is it in practice, is it kind of done wherever, or what would you say is more common?
I think it's done on the back end because also when we get the APIs, many times when we're working with external APIs, we do see this format when we are getting some information from an API. So we see that there is some of the information that is common like this, and then there are nested arrays. This is a more common format than repeating this information like this. So normally also these other official APIs that we have worked, they don't return us data like this. So they probably do this post-processing on the back before returning. Yeah, so yeah, I would say this is better. And also now it's just 2 entries, but let's say that you want to send a big amount of data, you also try to minimize the amount of data that you send. So instead of sending duplicated entries, so duplicated name and stuff, so you try to avoid this and you just group it like this. So of course, this make useful format is not a generic function. So this is very specific to this route. So to these results that we get, because it makes reference to the concrete things. So it's not something that you can easily reuse. Probably you will need to have some other also conversion functions if you have more selects and you want to send other information as well. But this is an idea of how it can work, and maybe you don't need for everything that you do. So you will not have all your selects, you will not be a joint select. So for the simple one, so let's say select all books. So if it is select all books, then you don't really have to do any conversion, you just send all the information back. This is mostly when you do this kind of joins that you have information from more than one tables, and then that it comes a bit dirty, so not as nice as you would like. And then a last thing is the guard that we have also seen when we did I think we have seen when we did the authorization example as well. And I don't know if on the databases example, we have seen this as well. So when we want to put some middleware in our routes so that we check if a user exists or if a user is registered, yes, or it has logged in, or if the user is allowed to see the resort, or if the resource exists. So let's say that we try to delete a book, but maybe before trying to delete a book, we want to see, does this book exist in our database already, or it has been deleted before? So we use these guards in many situations in the routes that we are creating to check something, to do some tests before actually doing the actual procedure. Because if we try to delete a resource that doesn't exist on the database, we will get an error. And we want to avoid this. So we first check, does this book exist? And then we delete it. Or when we want to modify something, we want to modify an entry. Before modifying it, we need to see if this entry actually exists. So this test, it's called the guard. And normally what we do is we have this small function that will do this select to see if this resource exists in our database. And then if the resource is found, also very useful is that the guard can add this resource that it has been found to an object that is called res.locals. This is kind of a local storage, temporary storage that we can store information so that the next functions can also use. So when we find something, we can add it to res.locals. And so the next function, the one that will try to do the delete or the update, will already have the item found stored in there. So what do I mean with that? Let's say that we have this get cat by a specific ID. So before actually sending back the cat, we want to ensure that the cat exists. This is, well, this is not the best example because this is very simple. So we just sent back the cat that we have found. It would be even better if we do it with a delete, but we can use a guard here as well. So we have this ensure cat exists. This is our middleware. We call this function before actually doing the last part, which is sending back the response to the user. And so this ensure cat exists. What it does is that it selects and it does these try cats and all these error messages. So it tries to find if the cats exist. If it exists, then I'm simply calling next. So whenever I have a middleware that I want to continue on success, I call next, and this next means that from here, I will go to the next function will be this one. So I will get in here if everything is okay. And so before calling next, I can actually store the cat that I have found. Here already, I did a select and I found something. So I can store the cat that I have found. It's stored from the database, it comes back as results.data. Results.data is a whole array. I just want the first item because it's the cat that will be one item. I can store it to this res.locals object. And so when I call next, this is already stored and I can directly use it in the function that comes next. So here I can simply send this cat that I have found stored in the res.locals. So the guard saves the cat for us, and we can simply now send it. And if there are errors, then I don't call next, and that means that all the process stops here, and I send back some error. So let's say that if instead of a get, I wanted to do a delete here, the first part would be the same, delete something with a concrete ID, and then first I need to make sure that the cat exists. So I would select the cat and everything. And then here, instead of sending back the cat, I could continue with doing my query for deleting this item. So there is a demo, but it is a bit long. So what we can do, I will show you a bit the demo, but I will send you the demo and we can discuss it also on Friday so that we can because this is a good demo. It's a demo that Jim, or one of our other instructors, created, and it is quite complete. It has a lot of the things that we have seen today. So, for example, it is a demo related to books, authors, and publishers. So there is also the many-to-many relations in here, and that's why the tables that we use here are one for authors, one for publishers, one for books. And there is this junction table, the book authors table, that connects authors and books by using book ID and author ID that are both foreign keys from this other table. Check here one detail, that this table doesn't have its own ID as a primary key. So all tables like the other ones, they have one ID that specifies this. We don't always need to use one like new ID. In this case, we can also create a primary key by combining two other IDs. So in this table, the primary key, it's not one new ID, because we don't really have any use for this. This is a junction table. It's just useful for joining together book IDs and author IDs. And instead, we create a primary key by joining together the book ID and author ID, because we assume that there will not be a combination of the two that will be repeated. So a book ID with an author ID will not be repeated, and it can be used as a primary key. So it's unique. We can do this also in other cases. So for example, a user, we may not want to create a user ID, but we may want to have as a primary key the user email that we kind of know that's unique anyway, connected with the birth date of that user. So connecting these two things together, we kind of make sure that this will not be repeated, and we can use this as a primary key. So this is another way of creating primary keys as well. And so there is some data inserted for authors, publishers, and books. See how this junction table, it's very simple. It just makes the connection between one book and one author. And so this, all this for creating, if you want to download it, I will pass you the code. You can download it, install it, and try to play a bit with it so that you see this code. This, we keep it in an initDB SQL file. I have sent you on Slack some instructions when we want to have more SQL commands written, instead of putting them in our database JS file, as we have done until now, that we had here our the creation of the table, we just had it in here. So it was in here to run the query to create a table. But maybe I want to create many tables and also want to insert some demo data. So my SQL, it's a bit long. Instead of putting it in here, I can simply read it from an SQL file like this. You have the instructions also on Slack if you want to try it yourself. So this is also a pretty common way of separating all the SQL commands. And like this, you can also pass it easily to someone else, so that when you do the handover, can create easily also the same structure. So here we have this, and then we have 3 different routes, since we have these 3 different resources, authors, books, and publishers. And for each one, we have our routes here. I have a methods for get all authors, get one author by ID, post a new author, or delete an author by ID. And so this has some of the things that we have seen today. For example, when we get an author, we don't simply want to get the author name and surname. We assume that when we try to get an author, we also want some more details, like the books of this author. So even if the get is for an author, I'm actually doing a left join to also get the books from this author. And for this, I need to use this intermediate junction table here and do kind of 2 left joins. So this is a bit more complete example. So how this works, let me start it. And this doesn't have any front end, it's just back end, and we can test it with Postman. So for this example, we assume that when I'm getting, let's say, all publishers, so let's go here to the publishers. and I'm getting all publishers, I'm simply getting all publishers in detail like this, one after the other, ID, name, and address for each one. But if I want to get some details for a specific publisher, so imagining also on the front end how this would be translated. I will have somewhere the list of all my books, but when I click on a book, I want to go to a detailed page of that book. So I need some more information, not just the name and the title of the book, but also which are the authors of the book, maybe which are the publishers. So whenever I'm getting like a more detailed request, then in this case, I don't simply return ID, name, and address of this publisher, so like a smaller select, but I also do a join with the books table so that I also get the books that this publisher has published. And here you see this format. It's, as we have seen before, it's translated to this more useful format. So the books are in an array. If I do 2, let's see 3. So the 3 publisher has 2 books. And so I return information like this. Same as if I do with authors. If I call all authors, then I simply get them because maybe I have like a general page where I list all authors with their name. But then when I click on one author, so let's say I click on author 2, I would want also to see which are the books related to this author. So then the information that when I do this get, the more specific get, it's produced by a join of 2 tables and also transforming the data to this more useful format. Okay, so when I do a get of all the authors, I simply send back all authors. This send all authors is a helper function up here that just does a select. But when I call a specific author here, first I need to do the guard to see if the author exists, and then do a more complete select to join the different tables together. So I don't want to waste more time today, so I'll send you this example. Maybe we can look at it more in detail also on Friday. Here, this join to JSON is this function that transform to a more useful JSON format. So you will see the structure is the same as we have seen in our example. We have this helper function, and we also have this middleware here, our guard, that checks if a resource exists, and if yes, it sends back the results, and if not, it sends an error. Okay. So questions? Let me stop this example. So you can install it, you can, in order to install it, you have to create the .env file with the code env example comes, but then you need to create your own env file and then run npm run migrate to install the databases and the demo data, and then npm start, and you can use it through Postman to check the different routes. I think there are the instructions are here. npm start. So you can use this as a reference to review some of the things that we have said today. And if you want to get more into databases, I can also pass you a couple of more resources so that you try some more things. So let me stop sharing. Okay, questions? Maybe you can include some of the things on your